The questions we've been looking at so far have been quite straightforward. However, the skills obtained from the previous videos are necessary to understand the concepts in this video. When finding the probability of repeated events, a way we could organize our information is using a tree diagram. A tree diagram helps identify all the possible outcomes as branches. Let's use an example to illustrate this. A bag contains 3 red balls and 2 green balls. A ball is chosen at random. The color is noted and the ball is replaced back into the bag. A second ball is then chosen and the color is noted. What is the probability of picking out 2 green balls, 2 balls of different colors? As mentioned before, we could list all the possible outcomes and then identify the number of outcomes that satisfy the question, but that is time consuming to set up. Instead, we can draw a quick tree diagram. A tree diagram represents the same information, but in a way that allows you to calculate probabilities quickly. The first branch represents the first selection of a ball from the bag. You can either pick a green ball or a red ball. Since there are different amounts of the colored balls, they won't have the same probability of being selected. In the bag, out of the 5 balls, 3 are red. This means the probability of selecting a red ball is 3 out of 5. There are 2 green balls, so the probability of selecting a green is 2 out of 5. As you may have noticed, the sum of any split of a branch is always a whole. 3 over 5 plus 2 out of 5 equals to 5 out of 5, or a whole. The question says the ball is replaced and another ball is selected. This means another set of branches are created. However, there must be a branch for each possibility. If a red ball is selected first, then there's a chance that the red or green ball is selected after. The same applies if a green ball is selected first. There's a chance a red or green ball will be selected after. The probability of selecting a red or green ball a second time hasn't changed since the first selected ball was replaced back into the bag. So our tree diagram looks like this. We have now set up our tree diagram. What we could do now is calculate the probability of each outcome. The first outcome is selecting a red ball twice. The probability would be 3 over 5 times by 3 over 5, giving us the probability of 9 over 25. Next, the probability of selecting a red first, then a green. Following the pathway, that would be 3 over 5 times by 2 over 5, which equals to 6 over 25. Next, selecting green first, then red. 2 over 5 times by 3 over 5 equals to 6 over 25. And finally, selecting green twice. 2 over 5 times by 2 over 5 equals to 4 over 25. We have now set up our tree diagram. Just a reminder, the sum of each branching point is always equal to a whole or 1, which means these 2 add up to 1. Also, these add up to 1 as well. The same applies for these 4. These 4 added together also equal to 1 or a whole. Looking at the questions, the probability of selecting 2 green balls we've already calculated. It is 4 over 25. We can confirm this by looking at the diagram with all the possible outcomes. There are 4 matchups that satisfy the first question out of the 25 pairings. When trying to find the probability of selecting 2 balls of different colors, well, let's see what outcomes satisfy this description. These 2 outcomes have 1 of each or different colors. Since they both are valid, the probability would be the sum of these 2 probabilities. The answer to the question is 12 over 25. Once again, we could see this would be true if we were to show this in our diagram. Pause and have a go at this question. Let's use what we've learned about tree diagrams to create one from this information and to find probabilities of these questions. The first day, the probability Mr. Marks will be late is 0.4. What do you think the other part of this branch represents? If he's not late, he must be early. Therefore, what would be the probability of being early? Remember, all parts of a branch add up to a whole. So the probability of being early is 0.6. Next, we do the same thing with the second day. The same probabilities. Now we could calculate the probabilities of each outcome, but it would be best to calculate what you need rather than all, so we'll leave the final outcome blank. Being late twice, That's this pathway, so 0.4 times by 0.4 equals to 0.16. The probability Mr. Marks is late twice is 0.16. Being late once, the pathways that Mr. Marks is late once are these two, as there is one late in each. We multiply through them to get 0.24 and 0.24. Since they both apply, we add them together to give us 0.48. The question was, what's the probability Mr. Marks is late at least once? We could also include this outcome to our calculation as there is at least a late there. So the calculation would be 0.16 plus 0.24 plus 0.24, which equals to 0.64. This is the final probability. To summarize, a tree diagram represents the probabilities for the possible outcomes in a diagram that can easily be used to calculate probabilities of different events. The sum of the parts of a branch always add up to one or a whole. Multiply through a path to find the probability of an outcome. Add the probabilities of outcomes that apply to a question.